In this lesson, we are going to introduce the concept of limit in calculus. Our goal is getting familiar with the concept of limit as independent variable approaches a number. Limits are a precise way of representing how a function acts when its independent variable is close to a certain number. For example, f of x equals x3 minus 4x2 plus x plus 6 divided by x2 minus 5x plus 6 is undefined at x equals 2. However, if we inspect the function values for x is near 2, we'll see the following trend. F of 1.5 is 2.5, f of 1.7 is 2.7, f of 1.9 is 2.9, and f of 1.99 is 2.99. That means when x is getting closer to 2 and it is smaller than 2, f of x is getting closer and closer to 3. Similarly, when x is getting close to 2 and x is bigger than 2, f of x is getting close to 3. This means as x gets closer to 2, the function f of x gets closer to 3. We say the limit of f of x as x approaches 2 is 3. This is the notation that we use to show the limit of f of x as x approaches 2 is 3. Let's define limit of a function as x approaches a number. Our definition is an informal definition of limit. If f is a function defined on some open interval that contains the number a, except possibly at a, we say the limit of f of x as x approaches a is L, provided that we can make f of x as close to L as we want for all x sufficiently close to a from either side, without actually letting x be a. Let's have some examples. Example 1. Limit of 3x plus 1 as x approaches 1 is 4. 3x plus 1 can be as close as possible to 4 when x is getting close to 1. Example 2. When x is getting close to 3, x2 is getting close to 9. Therefore, limit of x2 as x approaches 3 is 9. Example 3. We know f of x equals x2 minus 6x plus 8 divided by x minus 4, and g of x equals x minus 2 are equal when x is not 2. Therefore, limit of f of x as x approaches 4 is the same as limit of g of x as x approaches 4. That means limit of x2 minus 6x plus 8 over x minus 4 and limit of x minus 2 as x approaches 4 are equal. When x is getting close to 4, x minus 2 is getting close to 2. Therefore, the given limit in example 3 is 2. Example 4. Limit of x3 minus 8 over x2 minus 4 as x approaches 2 is the same as limit of x minus 2 times x2 plus 2x plus 4 divided by x minus 2 times x plus 2. We know a3 minus b3 is a minus b times a2 plus ab plus b2, difference of cubes. And a2 minus b2 is a minus b times a plus b, difference of squares. Since x approaches 2, x cannot be 2. Therefore, x minus 2 is not 0. That means we can divide both the numerator and the denominator by x minus 2, and our limit would be the same as limit of x2 plus 2x plus 4 over x plus 2 as x approaches 2. When x is getting close to 2, x2 plus 2x plus 4 is getting close to 12, and x plus 2 is getting close to 4. Therefore, the given limit is 12 over 4, which is 3. Example 5. To find the limit of 1 minus square root of 1 plus x over x as x approaches 0, we rationalize the numerator of the function. By multiplying both the numerator and the denominator by 1 plus root x, the limit would be the same as limit of minus 1 over 1 plus square root of 1 plus x as x approaches 0, which is negative 1 over 2. Let's recap. In this lesson, we learned the meaning of x approaches a. It means x is getting close to a and x is not a. We say limit of f of x as x approaches a equals L, and that means f of x is getting close to L as x is getting close to a. Thank you.